So let's take a look at a question regarding piecewise functions. If f of x is equal to x squared plus 1, if x is less than 1, and 3x if x is greater or equal to 1, is f of x continuous at x is equal to 1? And explain. Okay, so what we need to do here is, in order for us to determine if f of x is continuous at x is equal to 1, whatever hole gets generated at x is equal to 1 should be filled by the other function in the piecewise function. So let's test to see if there are any point discontinuities, and there should be a point discontinuity because one of the functions is not present when x is equal to 1, and this is specifically x squared plus 1, right? The function x squared plus 1 only exists when x is less than 1. So therefore f of 1 should not equal 1 being plugged into this equation. So 1 squared plus 1, which is equal to 2. So the point 1 and 2 does not exist, right? So this point would not exist on the graph, right? But f of 1 should be found in the function 3 of x. So if you do plug in x is equal to 1, it should be plugged into 1 for 3, and then you get 3 times 1, which is 3. So the point 1 and 3 does exist, right? So this guy exists, right? So in this case, because we do have a hole at 1 and 2, and the point exists at 1 and 3, right, this would not be continuous at x equal 1. So I'm going to show you guys this graphically. Alright, so let's graph this function on this graph, right? So let's first graph x squared plus 1 on this graph. X squared plus 1 looks like a quadratic function. So we know that the point 1 and 2 doesn't exist, right? Because in this case, the condition for this function is x has to be less than 1. So 1 and 2 will actually just kind of look like a hole, right? Whoops, let's just kind of move that there. So it's going to be a hole at this point. However, 1 and 3 should exist, right? So 1 and 3 should exist. Now, as x is greater than 1, the function should look like 3x. So if I do f of 2, then the function here would be 3 times 2, which is 6, right? So you would get 2 and 6. Let's put that here, right? And just be a linear function, right? So just kind of keep going, right, further on. Right, now in this case, let's take a look at x is less than 1. Well, if x is less than 1, let's do f of 0. F of 0 here is 0 squared plus 1. We plug it into this equation, and we get 1, right? So 0 and 1 will exist, right? And this should be concave up, right? And if we do f of negative 1, we get negative 1 squared plus 1, which is 2, right? So you can kind of understand how this would work. So this would be basically a quadratic. Right, and you can notice here that at this point we have a discontinuity, and a discontinuity is a break in the function. So this is the break or the discontinuity. Okay, and if you guys take future courses, specifically calculus, this is a type of discontinuity, and it's called a jump discontinuity. Okay, so it's not too important for us to understand, but there is a discontinuity in this piecewise function that's signaled by this break. Right, so therefore f of x is not continuous at x is equal to 1.